Hello, and welcome to the third hour of Module 1, Integer and Number Variables. I'm Brian Hauer, and again, I'm going to guide you through this. This is pretty much a review of the notes for this section in Quorum. So let's begin our discussion. You know, Today we're going to explore integer and number variables, which are essential components for storing and manipulating numerical data in our programs. Now, in our previous session, we covered text and Boolean variables. Today, we're going to complete our exploration of Quorum's four primitive variable types by diving into integers and numbers. These numbered data types will allow us to perform calculations, track quantities, and build more sophisticated programs. By the end of this hour, you'll understand how to work with whole numbers and decimal numbers, perform mathematical operations, and apply these concepts to solve real-world problems through programming. Now, overview of the learning goals and objectives for this lesson. So by the end of this hour, you will be able to store numerical information using integer and number variables. Use blank block templates to create code more efficiently. Apply integers and numbers in your programs, and use mathematical operations to modify variables. These skills align with several CSTA standards, including those related to data analysis, algorithmic problem solving. Before we dive in, I'd like you to consider this warm-up question. Think about various technology you use every day. Calculator, car speedometers, digital light switches, e-books, a microwave. What kinds of numerical data do you think these devices are storing or changing? Now keep this in mind as you explore how programming languages handle numbers. This hour builds directly on our previous work in text and Boolean variables, completing our foundation of primitive data types in Quorum. Variable types that we will review here are, they're the building blocks, again, as we said, for data in any program. In the left top, we have the integer variables, which store whole numbers without decimal points. For example, integer whole number equals 7. That's very simple. Then we have the type of number, which values with decimals, 3.14 or 2.5. And in the bottom, we have, again, text, which is characters in quotes, like hello in quotes or 42 in quotes. And then we have Booleans, true or false, which we talked about earlier. All right. These four primitive types are the building blocks of data in programming, and the same is true in Quorum. Now, so integer variables. Well, let's look at this one very closely now. Integer variables store whole numbers without decimal points. They can be most negative or 0. In Quorum, we declare an integer variable using the keyword integer, followed by the name, an equal sign, and a value. That's like most programs. So you see there, integer name equals value. An example there, integer count equals 5, integer temperature equals 10. This creates variable name count, like we did there, and the value 5. So you got integer count, that's the variable, and then it equals 5. When naming variables, remember these rules. Variable names must start with a letter. They can include letters, numbers, and underscores. They cannot have spaces or special characters. They cannot end with an underscore. So looking at the image on the right, you can see examples of integer variables declarations in the Quorum interface. Okay, and I know that's hard to see. Integers support several operations. Addition with the plus sign, subtraction with the minus, like we know, and then we have multiplication with the asterisk, and then division with the forward slash. And then mod, which is to show the remainder, is that's how we use it with mod. An important point about integer division, it always truncates the decimal point. For example, if you divide 5 by 2 using integers, the result is 2, not 2.5. The decimal portion is simply cut off. All right, so those are things to remember. Now, number variables. When we look at number variables, okay, unlike integers, number variables store numerical values with decimal points. They're used more for precise calculations where fractional values are important. We declare a number variable using the keyword number, followed by the name, an equal sign, and a value. All right. And then, so the examples up there that we have is number price equals 10.99, number temperature equals 2.5, and number pi equals 3.14159. Number variables support all the same operations as integers. You know, you see the number A equals 10.5, the number B equals 2.5. So the number sum A plus B would be 13, right? The number difference, A minus B, would be 8, but you have the decimal point. And multiplication would give you A times B is 26.25. And then you have A and B equals 4.2. So number Celsius is another real world example. Is like this could be done with Celsius. I know our equal signs are a little awkward on these screens, but number sign Celsius equals 25.0. Number Fahrenheit equals Celsius not times 9 divided by 5.0 plus 32.0 equals the result of 77.0 degrees Fahrenheit. So looking at the chart on the right, you can see the key difference between integer and number division. When we divide 5 by 2 using integers, we get 2. But we divide 5.0 by 2.0 using numbers, we get 2.5. Numbers maintain decimal precision, which is crucial for any applications. All right. So next, mathematical operations, which are in all programs, as we know. These allow us to perform calculations with our variables. This basic operations are the ones that we all know: addition with a plus sign, multiplication, subtraction, division, and the mod for modulus. Okay, like 5 mod 3 would be 2. That's the remainder. All right. So remember, these operations follow the standard order of operations. Remember, parentheses first, then the multiplication and division, and then finally addition and subtraction. Chart on the right shows the relative frequency of operators usage in typical programs. As you can see, addition and multiplication are the most commonly used, while modulus operator is less frequent, but still valuable in specific tasks. All right, so that is, so now next, blank block templates. We talked about this a little bit earlier, what it is. Let's talk about blank block templates, which are a helpful feature in Quorum blocks. Blank block templates are pre-programmed partial lines of code that can be expanded into complete code blocks. They help you write code faster without having to memorize exact syntax. To use a template, type the template keyword in a blank block, press enter. The system will automatically expand the template into a complete code structure. Control templates include for making decision in your code, repeat if for making decisions in your code, repeat for causing the number to be something repeatedly, and repeat while for creating loops with conditions. The image on the right shows examples of a repeat loop template in Quorum blocks. Templates are optional but convenient for both beginners and experts. They help beginners learn syntax patterns while allowing experts to code more efficiently. I encourage you to experiment with different templates to discover what they can do without memorizing everything. And that's a good skill to learn, especially with block coding, a good way to help you get started. So code examples here, and I'm not going to go through these, but you could take integer operation examples, number operations examples. We have the loop with integer examples. We We have the temperature conversion and example, and all these you can review. The slides will be in there if you want to review those. All right. So let's look at a little bit of classroom activities that there are out here. So when we look at some of these classroom activities, the first activity is integer practice. Now, this is just giving you some ideas, and also you will have practice problems that you can do with your students, which I'll talk about. Students create manipulative integer variables, performing basic operations, solving problems. They'll create variables for counting items, perform basic math operations, calculate remainders using modulars, and solve problems involving integer division. The goal is to understand how to store and manipulate information. The second activity is number practice. And students work with decimal values, comparing numbers and integers. They'll create variables for measurement, perform calculations with decimal values, compare integer and number division results, and solve real-world problems using number variables. The goal is to understand how to work with decimal values for precise calculations. Template exploration. Students experiment with blank block templates to create different codes. Try different basic templates, control templates, create a counting program using templates, and modify template-generated code to solve problems. The goal is to become comfortable with the templates of code and coding shortcuts. The fourth activity is a real-world application. Students create programs that solve practical programs using integer and number variables. Examples include temperature converters, tip calculators, speed calculators, currency converters, area calculators, and time converters. The goal is to apply integer and number concepts to solve everyday solutions. Finally, to look some wrap-up discussion, have students discuss which types of applications might require integers versus numbers and why. And the goal of this is to connect programming concepts to real-world technologies. This is just some ideas for you to use and a good discussion to use with your students. So to kind of wrap up this hour 3 is, let's just review a little bit. We have integer variables, which store whole numbers without decimal points, okay? We have number variables that store values with decimal points. We have, of course, the mathematical operations. And then we have the blank block templates that you can use, shortcuts to help you, code with code structure and help beginners learn syntax and expert code efficiently. And then, of course, we have real-world applications, calculators, time tracking, and all those. Now, the radar chart on the right compares integer and number characteristics across 5 dimensions: precision, memory usage, calculation speed, range of values, and ease of use. Notice that integers excel in memory efficiency and calculation speed, while numbers provide better precision and a wider range of values. These concepts have numerous real-world applications, including calculators, of course we said game scores, temperature measurements, and financial calculations, and so forth. So consider when you're discussing with your students, what types of applications might require integers versus numbers? Why would you choose one over the other? How do different programming languages handle integer and number operations? Are there consistent patterns? Math connections, how do programming concepts connect with mathematics curriculum? How might you explain these connections to students? And what activities would help students understand the difference between integer and numbers? And these are just some discussion questions that you could use with your students. And hopefully they're helpful. So this section is pretty much done. And you can work through the material, and I'll show you again. Everything we did goes along with this section here of hour 3. And this is basically, I just did a PowerPoint going over hour 3. And as you know, that each hour has the parsing problems that you can work through. And that is also in your packet. So we have the packet for the block coding for part 3, integer and number variables. Remember, this is what you can use with your students. You have a question to kind of guide them. Can you think of examples of technology that store change numbers? And then the students and yourself could fill out this as you work through the material. And then, of course, define some terms here and fill this out. This is all in the notes that are on the website. And then and then engage is, these are the integer practice problems. So this will lead right to the Parson problems that you have here that are also down here at the bottom. So you have these Parson problems here that you work through. And as you know, you can work through each one of these. And then you can do some with the kids, or you can work through this with the kids, or you can have them work with partners, whatever works with you. I'm just giving you some ideas of how to look at it as a teacher and look at it as a student. And then you have the number variables practice with the Parson problems as well. And then you fill out this material. Okay, this is the last section of this participation doc for Module 1. And you have a question to answer. And then if you go to the course, as we're looking at Module 1, and this is the integer practice, then you go to the wrap up and discussion. When you get to this section, this is where I have an answer key for all the problems. And I don't put that in there till the end, so I want you to try to work through it. But you will have all of them to use with your kids. This Google form is where you will, in this section, you will fill out the module wrap up and discussion. And then you will submit this whole document in this Google form that, if you click here, you submit it, you click on what module it is, and then you make sure that that's submitted. And that's how you get credit for that module. All right. And that is the conclusion of your Module 3. And when we get into the the next step, we're going to be getting into libraries next. And we will be, so don't forget to do your problems and work through those. And if you struggle, there are answers, but you can reach out to me as well, and we will review. So thank you for listening, and I look forward to seeing you at the live session coming up in November. Thank you.